Okay, let's just have a little bit of a look back at electrolysis, electron transfer in electrolysis and redox reactions. So remember, obviously in electrolysis, electrons are gained and lost. Typically, positive ions go to the cathode and gain electrons, which is reduction, and negative ions go to the anode and lose electrons, which is oxidation. So let's try and write some half equations for the anode and cathode just as a kind of revision of that material. And it's the best example of electron transfer and redox reactions that we have so far. So at the anode, like we said, oxidation takes place, and at the cathode, reduction takes place. So let's have a go at sodium chloride solution. Let's assume it's concentrated. What happens at the anode? Well, you have to fill this in, but the chloride ions and the hydroxide ions are both negatively charged in solution, and they would go to the anode. But in concentrated solution, the chloride ions discharge first. So the classic equation. Two chloride ions lose one electron each to become chlorine atoms initially, and then they form chlorine molecules spontaneously. At the cathode, in sodium chloride solution, you have sodium ions and hydrogen ions as the positive ions, as the cations. They both go to the cathode, but it's the hydrogen ions that discharge. Classic equation. Let's try copper sulfate solution. Now, here we have sulfate ions in solution, SO42-, and hydroxide ions. Both have a negative charge and go to the anode, but the sulfate ions don't discharge, so the hydroxide ions discharge in that way. The copper ions and the hydrogen ions from the water go to the cathode, but the copper ions, remember, are less reactive, so the copper ions discharge here instead of the hydrogen ions. With potassium hydroxide solution, you've got hydroxide ions as the only anion, so you get the same equation, and the cations are potassium ions and hydrogen ions. Obviously the hydrogen ions discharge. Fill all of those equations out on your sheet. Okay, this is completely new. Oxidation states, or numbers as they're sometimes called, they're synonymous, those two words. The oxidation state of a species is a measure of how many electrons it has lost or gained. Okay, so if it loses electrons, its oxidation state increases, and if it gains electrons, it decreases. But you'll see that more in a minute. We have to follow the simple rules. So these are the rules that it's worth learning because they will pop up at IGCSE. First one, the oxidation state or number of an element is always 0. So consider chlorine, Cl2, which is an element. It consists of only one type of atom. Its oxidation state is 0, which is written as shown. Copper is a metal, it's an element, again. And oxygen is an element, same way. That's the first rule. If you've got an ion, a simple ion, then the oxidation state is the same as the charge on the ion, apart from the sign is written on the other side of the number. What do I mean? I mean, if I've got a chloride ion, it's minus, then its oxidation state is -1. If I've got a hydrogen ion, which is plus, its oxidation state is +1. If I've got O2 minus, its oxidation state is -2. That's what I mean about the sign being on the other side. Simple ions, the oxidation state is the same as their charge. Magnesium ions, for example, Mg2+, +2. Next rule, the sum of the oxidation numbers in a neutral compound is 0. So in magnesium oxide, the magnesium oxidation state and the oxygen, or the oxide oxidation state, have to add up to 0. So magnesium is +2 because it's an Mg2+, oxygen is -2 because it's an O2-. They add up to 0. Aluminium chloride, a bit more difficult. Aluminium is Al3+, so it's +3. Chloride is 1-, so it's -1. Do they add up to 0? Well, at first glance, no. But because you've got 3 of the -1s, then you've got +3. 3 times -1 is -3. Add them up, 0. The sum of the oxidation numbers in a compound ion or a polyatomic ion is the same as the charge on the ion. It's the same as the charge on the ion. So, let's have a look at some polyatomic ions, some compound ions. OH-. We saw before the oxygen or the oxide was -2 and the hydrogen was +1. If I add them up, -2 + 1, it's -1, and that's what the charge is. So -2 + 1 is -1. Sulfate ions, a bit trickier. Oxide was -2, we saw before, but the overall number is 2-. And I've got 4 oxides. I've got 4 of them. So 4 times -2 is -8. Something plus -8 equals -2. Something plus -8 equals -2. You've guessed it, the answer has to be +6. Okay, so 4 times -2 is -8, +6 -8 is -2. This is the manganate 7 ion. The manganate ion. So the oxides -2, 4 times -2 is -8. The overall sum has to add up to -1. So something plus -8 equals -1. Yes, you guessed it again, +7. These ions, because they have these funny oxidation states on the sulfur and the manganese, then the names of the ions, technically, that's the sulfate 6 ion because of the oxidation state of the sulfur, and that's the manganate 7 ion because of the oxidation state of the manganese. We have to use these Roman numerals when there's potential confusion. There could be other versions. Next rule. Oxidation, using oxidation states, is an increase in oxidation state, and reduction is a decrease. So let's have a look at a reaction we saw before, lead oxide and carbon producing lead and carbon monoxide. Let's put the oxidation states in. -2 for the oxygen, so +2 for the lead, 0 for the carbon because it's an element, 0 for the lead because it's an element, and then +2 and -2 again. What's happened to the numbers? Well, what's happened to the lead? It's gone from +2 to 0. Reduction is a decrease in oxidation state. +2 to 0, so it must be reduction. The carbon's gone from 0 to +2, so it must be oxidation. In the end, it's much easier to use oxidation numbers and oxidation states, but right now it feels very new and perhaps a little bit confusing, so don't worry about it right now. But it's something to start to think about, and it's something that you can start to learn the rules of so that you can use it in exam questions. Okay, and the last little rule, we've mentioned it before, if there's 2 possible oxidation states of a particular element, for example iron 2 or iron 3, then we use Roman numerals to distinguish between the 2. So whenever you see iron 2, you know it's Fe2+, and iron 3, it's Fe3+. Iron 2 oxide, the formula is FeO, whereas iron 3 oxide, the formula is Fe2O3. If you're not sure about that, try writing it down and writing the formulae for those substances. Right, that's the end of this particular section. Try the questions, read the pages, and it's time for the end of chapter questions 2.